The first part of this problem is asking for the force between the two alpha particles when they are at a given distance apart. Now recall that from Coulomb's law, we can find the electrostatic force between two electrically charged particles by taking the Coulomb constant K, multiplying it by the magnitude of the charges of the two charged particles, and then dividing by the square of the distance between them. In our case, the distance between the two alpha particles has been given, and the problem statement also tells us some information about the magnitude of those charges. We're told that each of these alpha particles contains 2 protons, and 1 proton carries an electric charge equivalent to the elementary charge. So another way to represent the Coulomb's law for this case is K multiplied by the charge on particle 1, which again is 2 multiplied by the elementary charge, so 2e. And this is also the exact charge of our second particle as well. So instead of writing times 2e again, I'll just square the 2e we already have, and then divide by r squared. Now from this point forward, solving the problem is fairly simple. It's nothing more than a matter of plugging in the values that were given in the problem into this equation. So K is the Coulomb constant, which has a value of 8.99 multiplied by 10 to the power of 9, with units of Newton meter squared per Coulomb squared. Then we multiply by the square of 2 multiplied by the elementary charge, which has a value of about 1.6 times 10 to the power of a negative 19 coulombs. Don't forget to square it along with the 2, and then we divide by the square of the distance between the particles, which is given in the problem as 5 times 10 to the power of negative 15 meters. Don't forget to square that. If we put this into a calculator, then we find a force with a magnitude of about 36.8 newtons. And that is the answer to the first part of the problem. The second part of the problem, part B, asks us to find the initial magnitude of the acceleration of the alpha particles due to this force. Solving this part of the problem is a matter of applying Newton's second law. In other words, the acceleration experienced as a result of a particular force is equal to the magnitude of that force divided by the mass of the object experiencing that force. For us, the magnitude of that force is just our answer to part A, 36.8 newtons. And we divide this by the mass of the particle, which was given in the problem statement as 4.0026 daltons. 4.0026 daltons. But in order to keep our units consistent, we need to convert this from daltons, or atomic mass units, into kilograms. And we can do so by recognizing that 1 dalton is equal to 1.66 times 10 to the power of negative 27 kilograms. If we put this into a calculator, then we find an acceleration with a magnitude of about 5.54 times 10 to the power of 27 meters per second squared. And that is the answer to part B. And that is it for this problem. I hope this video helped you out, and if it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I'll do my best to help you out as best I can. That's all for now, and I hope you all have a lovely day. Bye-bye.